Electric field due to a charged disk. Consider a consider a ring of thickness dr at a distance r from the center O. Here we are considering a ring of thickness dr at a distance r from the center, and a axis is passing through the center, and we have to find the electric field at point P, which is this axis perpendicular to the disk like this. Okay, and the radius of disk is r, and surface charge density is sigma given. So we have to calculate at a distance P the net electric field due to this disk. So to calculate the electric field, we have to take a ring and we have to calculate the electric field due to ring, because we know the formula for electric field due to ring, and then we integrate from 0 to r. So here we have, consider a ring of thickness dr at a distance r from the center O. Area of ring will be dA equals to 2 pi r into dr. Now charge of the ring dq equals to sigma dA, sigma equals to 2 pi r into dr, sigma into 2 pi r into dr, because sigma is the surface charge density. So electric field at P due to this elemental ring equals to d, or d equals to 1 by 4 pi epsilon naught dq into x by r square plus x square to the power 3 by 2. We have calculated this value earlier. Hence the net electric field due to whole disk will be E net equals to 0 to r di, because one ring will be at 0 distance, and the last ring will be at distance capital R, or E net equal to 0 to r 1 by 4 pi epsilon naught sigma dq equal to sigma into 2 pi r dx, so sigma into 2 pi r into dr into x divided by r square plus x square to the power 3 by 2. Now x is fixed, so x will come out of the integration. So sigma into 2 pi x divided by 4 pi epsilon naught 0 to r dr divided by r square plus x square 3 by 2. Here keep in mind that x is here fixed but r is variable. Or sigma x, pi cancel out and 2 cancel 2. So sigma x by 2 epsilon naught 0 to r dr by r square plus x square by 3 by 2. We can solve this with the by substitution method. Here let r equal to x tan theta, then dr will be x into sec square theta d theta. Hence r dr equal to x square into sec square theta into tan theta d theta. Hence E net will be sigma x by 2 pi sigma x by 2 epsilon naught 0 to r x square sec square theta tan theta into d theta divided by, putting the value of r here, x square into tan square theta plus x square to the 3 by 2, or sigma x by 2 epsilon naught 0 to r x square sec square theta tan theta d theta, taking x square out of the bracket, x square into x square to the power 3 by 2 tan square theta plus 1 to the power 3 by 2, or sigma x by 2 epsilon naught 0 to r x square by x cube sec square theta tan theta d theta, and this will be 1 plus tan square theta equal to sec square theta. So sec square theta to the power 3 by 2 of sec sigma x by 2x 1 by x sec square theta tan theta d theta and sec cube theta. Now sec square theta will cancel sec square theta and will be left with 1 sec theta. So sigma by 2 epsilon naught 0 to r tan theta by sec theta into d theta. So sigma by, this imply sigma by 2 epsilon naught integration 0 to r sin theta by cos theta tan theta equal to, and 1 by cos theta d theta equal to sigma by 2 epsilon naught, and now cos theta cancel out. So sigma by 2 epsilon naught 0 to r sin theta d theta, or sigma by 2 epsilon naught under minus of cos theta 0 to r, and sigma by 2 epsilon naught minus of cos theta will be from the figure x by under root r square plus x square. Here we can see that this is x, and if we take here, then this will be theta, and cos theta will be cos theta, this x by and this length under root r square plus x square. So we have calculated sigma by 2 epsilon naught under bracket in the limit 0 to r minus x by under root r square plus x square, since tan theta equal to r by x equal to p by b, and cos theta equal to b by under root p square plus b square, so x by under root x square plus r square, or equals to minus of sigma by epsilon naught x by under root x square plus r square minus of x by under root x square plus 0 square, because here r is variable, so equals to minus of sigma by 2 epsilon naught x by under root x square plus r square minus 1 by x, or equals to sigma by 2 epsilon naught under bracket 1 minus x by under root x square plus r square along OP vector. So field will be along OP in the outward direction, vertically outward. So this is the formula for electric field at a distance x from the center of the disk. Now electric field due to annular disk. Here a annular disk of radius r1 and r2 is given, and we have to calculate the electric field on its axis perpendicular to the plane of disk, that is at point P at a distance x. So we can take a element at a distance r, and its area will be dA equal to 2 pi r into dr. So dq will be sigma dA into sigma into 2 pi r dr. Now d will be 1 by 4 pi epsilon naught, and dq into x by under root x square plus r square to the whole cube. This is the formula for ring. We are considering a ring. Now hence E net will be integration d, and our limit will be from r1 to r2. So r1 to r2 1 by 4 pi epsilon naught sigma into 2 pi r into dr into x divided by x square plus r square to the power 3 by 2, or sigma x by 2 epsilon naught r1 to r2 r dr by x square plus r square to the power 3 by 2. Or equals to sigma by 2 epsilon naught sigma x, or taking sigma x by 2 epsilon naught integration of minus x by under root r square plus x square to the power r1 to r2, or minus sigma by 2 epsilon naught under root x by under root r square plus x to r1 to r2, hence minus sigma x by 2 epsilon naught 1 by root under x square plus r2 square minus 1 by root under x square plus r1 square. So sigma here we have calculated integration. So sigma x by 2 epsilon naught r1 to r dr by x square plus r square to the power 3 by 2 equals to sigma by 2 epsilon naught. Integrating it, we will get minus x by under root r square plus x square r1 to r2 minus sigma by 2 epsilon naught. X by under root r square plus x square to the r1 to r2, or minus sigma x by 2 epsilon naught, putting the limit 1 by under root x square plus r2 square minus 1 by root 2 x square plus r1 square, or sigma x by 2 epsilon naught under root 1 by root under x square plus r1 square minus 1 under root x square plus r2 square along OP vector. Answer. Now example. Find period of oscillation if minus q charge is displaced slightly along the axis of annular disk, where and x is very less than r1 and r2. So here this is the situation shown. Here a charge of minus q is placed at its center and it is displaced like in the upward direction or downward direction, vertically. So we have to calculate the period of oscillation. Here f net will be equals to minus of fe, or minus of q into E annular, or minus of q into sigma x by 2 epsilon naught 1 by under root 2 x square plus r1 square minus 1 by root x square plus r2 square. We have calculated earlier this formula. Since x is very less than r1 and x is very less than r2, so x can be neglected in this formula. So f net will be minus q sigma x by 2 epsilon naught 1 by r1 minus 1 by r2, or equals to q sigma by 2 epsilon naught under bracket r2 minus r1 by r1 into minus x, or k into minus x. Hence f net proportional to minus x. So it is performing SHM because f net is proportional to minus x, so it is performing SHM. Now we can write f d2 m into d2x by dt square equals to minus kx, or d2x by dt square equals to plus k by m into x, and this is equal to omega square, and k is given by this value. Hence omega square equals to k by m, and omega is equal to under root k by m. 2 pi by t equals to under root k by m, hence t equals to 2 pi under root m by k. So 2 pi under root m by sigma q by 2 epsilon naught r2 minus r1 by r1 into r2, or equals to 2 pi under root m into 2 epsilon naught r1 r2 divided by sigma q into r2 minus r1. Answer. Okay. Next topic is equilibrium of charged particle in electric field. When a charged particle Q remains in electric field, it experiences a force F vector equals to Q into E vector, and for its equilibrium, the net force on acting on the charged particle should be 0. That is sigma f equals to 0, hence sigma fx equal to 0, sigma fy equal to 0, sigma fz equal to 0. This is in the component form. Here it is shown. For example, a q charge is placed and a force electric field in vertically upward direction. So because it is positive charge, so force will be in upward direction and weight will be in downward, and if it is in equilibrium, then Fe will be equal to mg. Since sigma Fi equal to 0, so QE minus mg equal to 0. This is like QE equal to mg. If the body is spherical, then Q into E equals to 4 by 3 pi RQ into rho into g. This is volume and this is rho density, mass density. So this will represent mass, and this is the g, acceleration due to gravity. Now if Q, we know that the Q is written as n into E, number of electrons or number of charge into E, 4 by 3 pi RQ rho into g. So hence n equal to 4 pi RQ to the rho g by E into E. So there should be total of number of electrons transferred to the body from the body, so that Q charge will arise on the body and it will remain in equilibrium. Next, find the tension in the string. Here a bob of mass m is hanged with a string, and charge on it is q, and electric field is in vertically downward direction. So the free body diagram is here shown. The tension will be acting on the vertically upward direction, weight in the downward direction, and also electric field in the downward direction. Because the body in equilibrium, so we can write T equal to mg plus qe. So we have calculated the value of T in this example. Next, find the tension in the string as shown in the figure. Here again a body is body of mass m and charge q is hanged with a string, and this ball is negatively charged, so electric field will be in the not negatively charged. This is showing any ball, and electric field is in this direction, so force on this will be in this direction, and it is in equilibrium, so we can calculate the desired value. So free body diagram is drawn here. Tension will be in this direction and mg will be in this direction. If this is theta, then this also will be theta. So in this direction t cos theta, and in this direction sin theta. In this direction will be electric force F equal to QE, and in this direction weight. So for equilibrium, sigma F is equal to 0. So QE minus T sin theta equals to 0. This implies T sin theta equal to QE. This is equation known. And for vertical equilibrium, sigma Fy equal to 0. So T cos theta minus mg equals to 0. T cos theta equal to mg, equation 2. So we can get the value. Dividing 1 by 2, we can get the value of tan theta in the terms of force and weight. Next one is simple pendulum in electric. This is the case of simple pendulum. This is a bob of length L clamped with the string, and is the mass. This arrangement is called simple pendulum, and we know that the simple pendulum has time period equals to 2 pi root under root L by G. Now we will see the example of simple pendulum in under the condition of electric field. So here let's see. So first we derive the time period of simple pendulum without any electric field. So here it is shown. This is a board of mass m, and the length of a string is L, and this is displaced in this direction. So if we consider this arc length is equivalent to a very small displacement, so arc length will be equal to x. Now here force is acting is weight in vertically downward direction, and tension in this direction. So tension has two components, T cos theta and T sin theta. Now F net equals to minus T sin theta, because T sin theta is acting in this direction. In equilibrium, T cos theta equal to mg, because in vertical direction it is in equilibrium. So T equal to mg by cos theta, and so one becomes F net equals to minus of mg by cos theta into sin theta, or minus of mg tan theta. Or minus mg into L by x by L if theta is very small, equals to mg by L into minus of x or k into minus x. So f net proportional to minus x, so SHM. Now m d2 x by dt square equal to minus of mg by L into x or d2 x by dt square plus g by L into x. Here omega square is equal to g by L because this value is omega square. So omega square equals to g by L or omega equals to under root g by L, and omega equal to 2 pi by t under root g by L, hence t equals to 2 pi root under L by g. So this is the formula for time period of oscillation in simple case. Now if a simple pendulum is placed in electric field, time period is given by t equals to 2 pi under root L by g effective. G effective, where G effective is the resultant acceleration due to gravity and due to electric field. Resultant of acceleration due to gravity and due to electric field. For example, here find the time period of oscillation. Here a electric field is acting in this direction, so we have to find the time period. So find the time period for we can write F equal to QE or M into AE equal to QE. M into A equal to QE, so A equal to QE by M. Now Fg equal to Mg. Wait. So M into Ag equal to Mg or Ag equal to G. Acceleration due to gravity, it is G. So one acceleration is acting in this direction, one acceleration is acting in this direction at any time instant. So G effective will be in this direction. So we have T equals to 2 pi under root L by G effective or equals to 2 pi under root L by under root QE by M to the whole square plus G square, because we have G effective under root AE square plus AG square, or under root AE QE by M into A square plus G square. Next example,